So it's lesson 10 today, and we're going to go over assignment 4, which will be due in a couple of weeks. And then our focus today, this week and then later next week as well, is unit testing. So we're going to talk about what unit tests are, why we do them. I know you've probably had a little bit of exposure to unit testing concepts previously. So we're going to talk about the kind of patterning of a unit test. We're going to look at review how dependency injection works in .NET Core, because we're going to have to understand dependency injection in order to be able to run unit tests. Then we're going to look at mocking up our database and actually creating and running some different unit tests in our .NET controller. So let's start with assignment 4, which is now posted to D2L. So you're going to work within the same application you've already been working on for assignments 1 to 3. The assignment is work 10%, and you have 2 weeks to do it. Okay? The only thing you need to submit to me is your GitHub link. You do not need to run anything on Azure or on Smarter ASP, because I need to run your unit tests. I need to download each project and use the Test Explorer in Visual Studio. You have to do your own work, and you can't simply download what I put up onto GitHub and change the words or any of it back to me. Okay, so you have to write your own unit tests for the assignment. So here are the actual requirements. Within your existing solution, you're going to create a unit testing project and create a test class for only one of your controllers. So everyone has at least 2 controllers. You don't need to unit test both of them. You just need to unit test one of them. You're going to write unit test for the methods in one controller to get as close as possible to 100% code coverage. This will be in the neighborhood of 24 tests, but it may vary a little bit depending on the code in your controller. Some of you may have a few fewer tests, some may have a few more unit tests. You're going to use an in-memory database to create mock data. We're going to do this in class today. You'll need to make sure that in all the return view statements, you explicitly name the view that should be returned. Again, we'll do this today and you'll see why in a little bit. You can also use this code to simulate an error if you want to simulate an error in your unit test and make sure the errors are handled properly. So you will need to do this in the create and edit post methods. So what happens when an invalid object is submitted by the user? You can use this code that I've bolded to simulate that condition. And you should just make a minimum of 2 commits to GitHub sometime over the next couple of weeks. So 2 marks for setting up your test project and mock data. 8 marks for your suite of unit tests and 1 mark for version control. This is our final assignment in the course, although we will do a lab next week in class that's designed to actually help you complete the assignment. You could get started on the assignment after today's class, but you probably won't have everything you need to do the whole thing until after next week's class. But you could certainly get started and do some of it between now and then if you wanted to. Excuse me. Are there questions about the assignment? Two weeks from yesterday. So you could probably get about half the assignment done between now and next week's class. And then, as I said, our lab next week will be in class, but it's designed to help you with the more advanced unit tests on the assignment. Now, looking forward at our schedule as well. So we do actually have 2 more classes. Going to open our syllabus up for just a second. I know that most of your classes are ending. Is it next week? I think most of your classes end next week, but we will have a class on Monday the 6th. That's one of the extra days for missed classes because we did miss two lessons, right? We missed one due to Labor Day and the second one due to Thanksgiving. So we will do a class on building a REST API on that one day on the 6th. It won't be a super complicated class, but I do want to go over REST API, and as it will be included on the final exam. Okay, so we're here today. So I think most of your classes end next week, but we will have one in 2 weeks. And I will let you know the date of the exam. I haven't seen a date yet for our exam. I will send out an email as soon as I know, which I don't know if they've scheduled it already. Let's have a quick look. Maybe our exams have been scheduled. Okay, I will have to get back to you on this one. Megan, the exam for our class has been scheduled on the 11th. Okay, do you have the time? Did you get a time for that? Okay. So the 11th is it's on Saturday, I guess. I think the 11th is a Saturday, unfortunately. Okay, well, sorry about that. Out of my hands, I wouldn't choose to give you an exam on a weekend, but not really very much I can do about it. Okay. Thanks, Megan. I will double check and I'll post that as well. Post the date to D2L. Okay, so before we start unit testing with .NET, I know you've probably looked at unit testing a little bit before. I think in one of your Java classes, using the chat. What can you tell me about unit testing? What do you already know about it? What do you remember from your Java course? Okay, so you give it different conditions, and then we can test to see whether those conditions work or break. Okay, yep. Thanks, Mason. It's a good description. Yep, and it makes it easy for us to check our code. Absolutely. Yep. Anything else you remember or you might say about unit testing? Anything else you remember? Did you do testing with it in Jarrett's class? Okay, Xavier says it's testing whether you get, okay, with Jared, thanks, Mason. Testing whether you get proper outputs. Yep, absolutely. Okay, so here's a follow-up question for you. It's useful, Megan says, useful for writing working code, especially if you actually write the tests first, which is true. We didn't actually do that in our course, but there's a whole methodology called test-driven development, right, where that forces us to think about the outcomes of our application before we actually write the code. It's a great point. Thanks, Megan. What's the difference between unit testing and other kinds of tests? What other kinds of testing is there besides just unit testing? And how is unit testing different from some of the other kinds of testing available? So it'd be a great interview question for a junior developer. What kind of tests are there, and what differentiates unit tests from other forms of testing? There's probably 3 or 4 other popular types of testing besides unit testing. You can guess if you don't know. That's fine. Okay, yes, we might have UX testing. Yep, that's right, Megan. Usability testing. So often that's from a user experience perspective. Okay, yes, Austin, we could. That might be part of unit testing, typically. We'll give you a hint. Unit testing is it's at a very granular level. Okay, Chris, yeah, can you explain what smoke tests are? Okay, yep, tests for things like big failures in code. Yep. What about testing for performance? Right, what's it called? We write an application, it's running fine on our local server, but then we release our application and suddenly we now have lots of people using it. We actually want to test that scenario before we put our application into production. What would that kind of testing be called? Where we're simulating, yeah, thanks, Jacob and Owen, like a load or a stress test, right? Where we want to use some automated test tools to see, well, what happens if one method gets called by 10,000 users concurrently, for example. So we can do load or stress testing. Yep. In our unit testing, it's very granular. So typically we write a unit test at the function or method level. So we're typically testing the behavior of a specific method. And then within that unit test, we need to evaluate what are all the possible things that could happen, what are the different results that are available in this method, and we would actually want to write a test for each one of those. So that's at a very, very granular level. We also have another kind of testing that's the opposite, where we want to test different pieces of our application and how they work together. It's almost the opposite of a unit test. Anybody know what that kind of testing is called? When we're checking how the different components. Yes, thank you, Jacob. That's integration testing. So right now, our application, we actually have 3 different components, right? We've got the MVC application we built in C#. And actually, we're using 3 other components that all live outside of our MVC application. So for integration testing, we would want to test how our web application interacts with all 3 of those components. What are those other 3 components that we've included in our bookstore? Yep, the database is one. So if we're checking how well our application interacts with the database, yep, that's a form of integration testing. The payment, the Stripe payment gateway we integrated last week, that's also integration testing. Okay. There's one other external component that we're using. What else are we using besides the database and the payment component? Okay, yes, Chris, I wasn't really thinking of the hosting environment, but that's true. But there's also something that's baked right into our web application. We've got code to another service. That we would have to integration test. Yes, Hannah, that's right, the Google login, right? So all of that kind of testing where we're checking how does our application work with this other service or component, that's integration testing. So in a production application, we probably would do all of these, but for now, we're really going to just focus on unit testing. Thank you, Megan. Thank you for the link. Okay, so yes, they did. Here we are. It's a Saturday the 11th from 1 to 4. I will also update that and make an announcement on D2L as well. I appreciate that. Let's just go here for a second. Testing is also underrated from a jobs perspective. Okay, so we all think about, we're training you as programmers. So going into quality assurance isn't necessarily something that a lot of people think about. However, it's a part of a lot of jobs. It's also an excellent place to start. It's a really common opening for junior developers to do a co-op or get started, where instead of you writing a lot of your own code, you're getting to evaluate and test code written by other developers. So it gives you a window into seeing how things are done and what good quality assurance processes look like. Right? And actually, interesting, this one came up. It's a local job here in Aurelia, and a number of graduates of our program actually work here at CareDov. So they're looking for software quality assurance. You need to know Java, remote work. Yeah, you guys are probably qualified for this by the time you graduate. So it's a very underrated way to break into the job market, performing quality assurance. Okay, and learning about this stuff. So here's one right here. Junior Quality Assurance Intern Co-op. What are they looking for? Second or third year student. Vue, HTML, React. So if you're struggling, looking for co-op or summer job for next summer, this would be an area I would encourage you to explore. I'm also just gonna give you a chance to read this for a second. So this was a quote by Scott Hanselman, who's been one of the most prominent, well-known ASP.NET developers for many, many years. And he describes, I won't read it to you, you can read it on your own, take a minute. He describes a really common scenario developers face all the time. So one of the common challenges we face when we're updating applications is that we fix something or we add a new feature, but then it breaks old code. So this is one of the things that automated unit testing is designed to catch. If we've got a good suite of unit tests, we know we can confidently add new code or make changes, and then we can run our tests on all our initial code, and it's going to show us if things that were working previously have now been broken. This is also known as regression testing when we're testing old code. And this is particularly a common problem when we make updates to applications that were written a long time ago. So either we write the code today and then we're updating it, a year from now, or maybe we're updating code, we get hired and we're updating an application that somebody else built that we maybe don't have a really high level understanding of. So unit testing kind of helps protect in this scenario. It protects us from fixing one thing while breaking something else that used to work. I'm going to pause and just play you a really quick video here. So I put this link up on D2L. This is the LinkedIn Learning, this .NET Core controller testing. So there's a little tutorial here. It's a couple hours from last year by Irvis Trupia, who's an excellent .NET developer. His LinkedIn Learning tutorials are very high quality. So it's a couple hours. He goes over there are three different frameworks in .NET for unit testing. There's MS Test, which is integrated right into Visual Studio, and a couple other ones. We're going to use MS Test. And he does some sample on unit testing, but just to give you a preview of MS Test, how it looks, we'll just pause here for a minute. Sorry, I assumed you could hear the audio. Anyway, it's just there for a reference. It is worthwhile probably going through the whole tutorial, but we can get started in our project. So what we're doing is also adapting. There's also a tutorial series. It's a bit old. It's 6 years old now, from Visual Studio Magazine, where I've sort of taken their unit testing tutorial and then modified it, updated it, and kind of repurposed it so that we can unit test with our last chapter application. So let's go and open up our project. And we'll get it running. Xavier, sorry, my friend, I don't know where you are. It's snowing here again. The sun is gone. We're back in the snow. Yes, it was, sadly. Hope you have your snow tires on for those of you who have a vehicle. I just got mine done. Okay, so our app is running. So let's play around a little bit. Let's look at kind of some of the unit testing basics here. I'm going to close up and close all the tabs we have open. Megan, you're a snow fan? I am not, but I'm glad you are happy. So open up your Solution Explorer, and you'll notice here up at the top it says Solution, the last chapter, 1 of 1 project. Our Visual Studio solutions allow us to have multiple projects in one solution. So we're going to need to kind of leverage this functionality. So we've got our web project here. We want to add a unit testing project to the solution. So the unit tests don't go in the web project themselves, and they don't get deployed to the web server. So I'm going to right-click my solution, and I'm going to add a new project. And in this search for templates box at the top, I'm going to search for test. And we get a whole bunch of different testing projects. I want this one here, the MS test project. So this, as it mentions in that LinkedIn learning tutorial, there's 3 different common unit testing libraries we can use. There's MS Test, which probably has the best Visual Studio integration. So that's the one we're going to use. There's also NUnit, which was the first one that came up, and XUnit. They're all similar. They each have their advantages, disadvantages, but they're not too different. So I want an MS Test project, and make sure you pick C#, because there is an option for Visual Basic as well. So we want an MS Test project that can run on .NET Core, on Windows, Linux, and Mac OS. So pick MS Test project. I'll call it the last chapter tests. Same name as our web project with the word tests on the end of it. It'll use .NET 5, which is our current framework version, and then we can create the project. So now it says, before where our solution says 1 of 1, it now says 2 of 2. The web project is bold because that's our startup project. When we run the application, it runs this. So we actually get a class here called unit test 1. It's public, and it's got this test class decorator and a method, one test method. So every unit test has got to have that test method annotation above. Every test class will also need to reference the Visual Studio unit testing library. Now I'm going to refactor this. I'm going to rename this. So I'm going to, in Solution Explorer, I'm going to right-click my unit test 1. I'm going to rename it to home. I'm going to call it dummy controller test. And then it asks, do I want to rename all the references? I'll say yes to this. So that's going to change my class name up on line 6. So what we're going to do is we're going to build a simple controller up in our web project, and we'll write some really simple unit tests for that controller, just to see how the unit testing works. And then after, we will unit test, I think later we'll start unit testing our books controller. So in the web project, I'm going to right-click controllers. I'm going to choose add a controller, and I just want an empty controller that I will call dummies controller. And in here, Visual Studio automatically, as we've seen many times already, whenever you create a controller, even if it's empty, it will automatically give us an index method. So now we can try to unit test this method. So for now, I'm not going to make any changes. We'll make a few changes in here a bit later, but not yet. So just generate the empty controller. And then we can go back to our controller test. I'm going to change my first unit test name. Test method 1 isn't very helpful. So the standard kind of pattern for creating a test name is we usually include the name of the method we want to test. And then the rest of the test name describes what are we actually testing. So we'll call this index returns something. So we want to check when we call the index method of the dummies controller, we want to check that something is returned back. It's not really a great test, but we're going to go will make them incrementally more complex and incrementally more meaningful. Now, in unit testing, and you probably did this in probably similar to what you did with Jarrett with JUnit, we basically have 3 steps to a unit test. We've got arrange, act, and assert. Do these look familiar at all? What do each of these steps mean? What's arrange, what's act, what's assert? So this is our standard kind of process for writing a unit test. Any ideas what these steps mean? All right, exactly. So arrange, set up any objects bars needed. Yep. So the arrangement is the setup. So what does the act do? So first we're going to kind of set the stage. What happens in that act, in that act part? Yeah, exactly, Chris. So we'll execute the method we want to test. Yep. And then what happens in the assert step? Yeah, that's right, Megan. So we will evaluate behavior, see if it matches the expected behavior. So does the method do what we think it's supposed to do? So this is our general pattern for all unit tests. So what do we need to do here if we want to, so we want to test out that this method returns something. So we'll need, what should we do in the arrange? What object are we going to need in order to call the index method? We are going to need an object in this case. What object do we need to instantiate? Got it. So I'll create a controller variable. So we want to instantiate an instance of our dummies controller. Notice we've got 2 separate projects. So that dummies controller is not visible. The controllers in our web project are not visible to our test project. So in my code hinting, it wants us to make a reference to the web project. So I'm going to accept that reference here. That actually will do 2 things. It adds a reference on line 2. And now if I open up the dependencies on my unit testing project, notice it's now added a project reference from the unit testing project to the web project. So now within our unit test, we'll be able to explore. This exposes the classes inside our web project. So now notice it recognizes, sees the index method. So we're going to call the index method. And then we're going to assert dot we're not actually checking yet what kind of result we got. We're just checking that there is something returned, that the method isn't void. So let's save that. And now there are many different ways to actually run a unit test in Visual Studio. I'm going to click on the test menu. I'm going to open up my Test Explorer. So in Test Explorer, it tells me there's one test in the project. I have no tests that have passed, no tests that have failed, one new test that has never been run or evaluated. So I can click either of these. This runs all the tests, or this will just run it. So I'll say run all tests. Now I get a green check mark. I get one here. And it tells me that my dummies controller test passes. With unit testing, it's just a simple pass-fail. There's no other evaluation here. Now, we've got the ability to create playlists. So if we want to group a bunch of tests together, so we can just run those tests in a playlist, we can do that. If I go back here now, I get a little green checkbox at the top of the method saying the last time that this test was run, it passed. The other neat thing is if I go to my dummies controller, notice now it says there's a reference and one of one tests that call that method pass. So Visual Studio gives you almost like a little scorecard on each method. So you know how many unit tests there are and if those tests have passed successfully or not. Now, I don't know, when you did JUnit, I assume it had some kind of little indicators like this as well to you, some visual cues that methods were covered by tests and what the status were, or is this kind of new? I haven't used JUnit before, so you got more experience with it than me. Okay, no one wanted to tell me. We've also got a couple other tools in the test menu. I click on test, and I know you've probably seen this with JUnit. It just gives a X pass or failed. Okay, thanks, Megan. If we go to analyze code coverage, now this window is kind of cumbersome to use. So it gives me this hierarchy. I can just expand this here. If I open my hierarchy and open my web project, and then I open my controllers, so it tells us that, almost 100% of the code is not covered by unit tests here. But if I look at my controllers and my dummies controller, it says there are no blocks of code not covered, and 100% of the blocks are covered by unit tests. I've also got this little button here that says Show Code Coverage Coloring. If I click it, notice this turns blue. meaning this method is fully covered by a unit test. Now, it doesn't evaluate the quality of our unit tests. Our unit test is actually kind of lousy here, but it does tell us that there are all of the different results or execution paths in this method. There is only one. It's covered by a unit test. If I go and look at, let's say, our books controller, everything in the books controller is red because we haven't written any unit test to cover any of this stuff. I don't think so, Mason. I mean, there is a way that we can initialize things globally so that every test, we don't have to do the same arranging over and over again, but not in terms of a template to actually generate the test. Not that I'm aware of. I shouldn't say there isn't, but I've never seen a tool like that here. I'm not familiar with that. I don't know. Let's see. I haven't tried this, so I'll try create unit test. What is this? So you can do it for a single method. You can generate a template here. I haven't tried using that. I have to look at it a little more. So our test isn't very good. We'll leave it. Let's try and write a better test. What would be a better test than just asserting that the result is not null here? We'll leave this unit test, but I'm going to write another one. So I'll create another test method. We'll start with the word index. What should actually happen in this method? Like right now, if our method returns, a JSON object, our unit test is going to pass. What more specific action do we actually want to check for? That would be better than just checking that the view doesn't return a null. Yep, we could check that it's a view. Okay, I think that's a good idea. And I think there's something else. So we could check that it's a view. Is any view okay? Does it matter what view gets returned? Like if we return the view, book/details. Yeah, we should maybe be checking that the view is index. Mason, we could check the number of characters, but I think maybe we will check that it returns the correct view. We'll say index loads correct view. Now our arrange and act are going to be the same. So I'm just going to copy those. Okay. So we're testing same method in the same controller. So now we've got our assert. Did the correct view get returned? So in this case, we're going to use assert.requal. requal takes two parameters. What did we expect and what did we get? So we expected the name of the view to be called index with a capital I. And now we can evaluate our result.viewName. Well, we're going to try to evaluate the result.viewName, but it didn't quite work. How come? What is this error telling us? The code's actually not wrong on line 32, but we're going to need to do something to fix it. iActionResult does not contain a definition for view name. So how come our view name property isn't available? If we look at the return type of our method. This has to do with the .NET class hierarchy. Go back here, right? So our method returns this iActionResult interface. So how come, why isn't view name in this list? So our method returns an iActionResult. This is a parent object. It's a parent interface. We're not explicitly returning a view here in the method. We could return a view, but we could also return other subclasses of iActionResult, things like a not found response or a JSON object. We can actually see this in our books controller. So for example, when we call details, if we have no ID, it doesn't return a view. It returns a 404 not found response. This is also a subclass of this iActionResult interface. If we want to actually get the name of the view, we have to do a cast. So if we take that iActionResult that gets returned, and we explicitly say this return type is a view result, it's not an HTTP code, it's not a JSON object, it's not a redirect, it's a view. Then notice now my error here goes away. In order to do this cast, however, our unit test, it's got no knowledge of MVC, so it doesn't know what this view result is, which means it needs this reference to Microsoft.NET Core.mvc. So if we add this reference, now we can call index, cast our iActionResult specifically to a view, and now we have access to parts of the view like the view data, the view name, or later the data model, which we'll get into a little bit later. So we can actually check the data in the view if it's what we were expecting. So I'm going to save that, and then I'm going to go and run my test again. Now I can also run the test right from here. I could just right-click it and choose Run Test. That's weird. Okay. So our original test passed, but this one failed. And if we click on it, it tells us we expected index, but there was actually no view name here. Well, that's really weird, isn't it? If I go to /dummies/index in the browser, oh, okay. Well, we do need to create a view. So we actually have to do two quick things here to fix this. Number one is we need to create the view. I know we're almost due for a break. I'll just fix this up. So it says one of two. I'm going to right-click my method name and choose Add View. We'll just create an empty razor view called index. So it gets created at views, dummies index. You can just put on. This is just a dummy page for testing. So this should load in our browser now. It does. So I just quickly right-clicked and chose Add View. I'm going to try my unit tests again. I can go back to my Test Explorer, run them all. Still fails with the same error. Weird. And my page is loading. It's loading index. So why is it saying my result.view name is null? I'm going to put a breakpoint here and I'll try to debug my test. So I'm going to right click and I'll choose, debug test. And I'll use my F11 key. So it creates my controller. It calls index, which returns a view. So far, so good. So here's my view result. But notice I have a view, but the view name is null. Well, that's kind of weird. Right? Why would the view name be null? It seems to work in my browser. And now my test is going to fail, right? It says my view name is null. So to fix this, we actually need to make one small change here, which we're going to do, and then we're going to take a break. We're going to change something on line 13. Any ideas what we should do here? It actually doesn't, Megan. No. The browser, the web server knows enough to show the page. But from a code perspective, the view name isn't set. So how could we explicitly set the name of the view that's being returned? We actually did it in the very first class. What can we do on line 13 to be very explicit about which view? Yeah, that's right. Thanks, Chris. So return view is overloaded, right? We've just been mostly returning empty or one with a data model. But there's an overload where we can return as a string the name of the view as a parameter. So this won't affect it in the browser, but it should fix our unit test. It still runs. And now I'm going to run all my tests. And now both of them pass. So I would suggest this is better code. Yes, it does work without the name at runtime, but the testing is helping us write better code. It's saying you shouldn't just be returning any view and hoping the right one gets loaded. You should be explicitly returning a view that has the name of index in this case. So now we get a green checkbox here as check mark here as well. Okay, so this is a case where our unit testing is helping us kind of improve the clarity of our code. Okay, it is 1:59. Let's take a break here. I will upload to Git and we will come back and work a little more with this, and then we'll start into unit testing our books controller. Let's take a break here.